All right, time for everybody's favorite, right? Word problem. Uh, what we've been learning about quadratics is actually useful and can be very helpful in certain scenarios. So let's take a look at the second problem here, and then I'll leave the first problem for you to do later. So, a stonemason has enough stones to enclose a rectangular patio with 60 feet of stone wall. If the house forms one side of the rectangle, what is the maximum area that the mason can enclose? What should the dimensions of the patio be in order to yield this area? Alright, so can you imagine this? We've got a house. Let's do a bird's eye view of the house. So pretend like this is the house. And then we're going to put a patio. We could make a patio that's long and narrow like this, right? So that would be one patio we could make. Or we could make the patio maybe wider and narrower. The key though is we only have 60 feet of stone wall. So whether I make it one way or another, we can only do 60 feet of wall. So what I'm going to do is I'm going to call this dimension x and this dimension y. And the reason I'm going to do this is I'm going to do this in a general sense and set it up so that I can find an equation for the area, because that's what I'm interested in. I want to maximize my area here. With the 60 feet of stone wall, I see we have two things here. I have a restriction that I don't know what x and y are, but regardless of which patio I use, I can take x plus 2y, and that can equal 60. It can't be more than 60. And this is nice because it then gives me a chance to relate x and y together. If I solve for x, you know what? I'm going to like it better later on if I put negative 2y plus 60. This tells me that if x is the width, no, I think I would call x the length, and y is the width, that now one of the x's, one length plus two widths equals 60. That's going to be the largest patio space. And that relates that the length should be 60 minus twice the width. All right, we're interested in area, so let's go back to that. If I want to write an area function in terms of x, normally I would just take x times y, the length of the patio times the width of the patio. But here I want to get my equation all in terms of one variable. So what I can do is I can take this, I'm going to change the color here. What color should we go with? I'm going to avoid purple and blue. Maybe I'll go with orange. I'll go with orange. Alright, so what I'm going to do now is I'm going to rewrite my area function as x, but instead of x, I want to put what x is equal to. I want to put it as negative 2y plus 60 times y. Now, if this is the first time you've seen something like this, you might be wondering, like, why? What's the point of this? Let me show you. If I distribute this, I now get a function of the area as negative 2y squared plus 60y. It's a parabola. Do you see that? In fact, at this point, we could graph it if we wanted to, and we could find the maximum area right here. In fact, let's do that. Alright, so y equals, what was it? Negative 2y squared plus 60. Oh, this is going to be a little confusing. you might be thinking, why am I writing x? Well, that's how Desmos is set up. Do you see that? Negative 2x squared plus 60x. I'm just changing it. So these x's are in Desmos here. You can see I'm really zooming out here. It's a very skinny parabola. I'm going to change my settings. So my y-axis I'm okay with. My x-axis I'm going to go from maybe negative 5 to 30. Okay. And so this is the area. What this means, I maybe should use W and L here. That here, you can't see. That's okay. If I hold my finger there, what this tells me is if my width is 6.35 feet, my area will be 300. If my width is 10 feet, if the width is 10 feet, the area will be about 400. All the way up here, you see the maximum area is when the width is 15 feet. So x on this equation, but back here, y is 15 feet. So that's saying at 15 feet, I have a maximum area. I forget what it was now. 450. 450 square feet. All right, but there is a way to do this without a graph. So let me show you that quickly here. Do you remember that equation for the line of symmetry? This is supposed to be symmetric. I'm sorry, my picture's not. But I can take the line of symmetry to be x equals negative b over 2 times a. And do you see when we do that, we get 15 here? So if x is 15, well, again, I'm getting myself in trouble. Let's call this y. Because this y really means width. It doesn't mean the y value of the graph. So y is 15 here. If I know that, I can come back up here. Well, and you can think about this in terms of the stone wall as well. We can take the length is negative 2 times 15 plus 60. That's going to give me 30. So what is the maximum area? The maximum area we found would be when the width is 15 and the length is 30. So that max area would be 450 square feet. All right. So let me see if I can clarify that just a bit. Okay, so regardless of the size of the patio, the shape, we can always think of a rectangular patio off of a house. You see, we don't need any stone along the house. In fact, we wouldn't want a stone wall along the house. So we have x is this dimension, y is this dimension. Okay, and so I did 2 patios here, but in the green, we're doing any patio. So whatever you pick for x, we can figure out what y would be. Whatever you pick for the length, we can figure out the width. We then use that to relate the two, length and width. The length is 60 plus negative 2 times the width, which makes sense with our stone wall, right? You would take the 60 feet minus 2 times whatever the width was, because you need that amount here and here. You then put that in the area equation, and you come up with a function that shows you the area given any width that you pick. Any width you pick, it'll jump straight to the area without having to calculate the length. When you do that, you want to find the maximum area. You can do that with a graph. You can also use the axis of symmetry formula, which is negative b over 2a. Either way, we find when the width is 15, the area is 450 square feet. The length then we can find by taking 60 minus 2 times 15, which is 30. So the dimensions are 15 by 30. The area is 450 square feet. All right. This problem up here is another similar type problem, but here it's not up against a house. You need bricks to go all the way around the garden. So pause the video and try this on your own. Here is the solution. You can take a look at it. Thanks, guys. Have a great day.